Hello, can you hear me? Okay. So let me start. So I think this is one of the first talks about Fedora Haskell and the Fedora Haskell SIG, and so this is it's really a packaging talk, but this talk is more focusing on the tooling related to our building of Haskell packages in Fedora. So yeah, my name's Jens Petersen. I work for Red Hat, also in Fedora. And in my day job, I mostly work on internationalization, but I'm also quite interested in Haskell. Just one. Have any of you used Haskell at all? Anyone? Oh, just a few people. Okay, great, awesome. I'm not going to talk a lot about Haskell today. This is not really a technical talk. It's just this slide. I just highlighted a few nice features about Haskell. So Haskell's a functional, pure language. So has lazy evaluation, and particularly important also maybe is the typing. It's statically and also it's strongly typed. So Haskell programmers try to push types a lot to try and structure their programs and also to avoid, compilation errors and runtime errors and so on. And it also has good concurrency, GHC particularly has good support for concurrency. Does anyone know any Haskell packages at all? Anyone? Oh, yes? Shall I try? Oh, yes. Anyone else? Okay. I wrote a few down here, so maybe you know some of these. I don't know. Pandoc is fairly well known, I think, like a markup conversion tool. There was Xmonad. Xmonad no longer works with Wayland, but I believe someone is working on something like that. There's Git Annex and HLedger, also the Shake make system. Haskell's also very good at making programming languages, so there's various languages like PureScript and Elm and so on that are written in Haskell too. A little bit more about who's using Haskell. So, lots of companies are now actually using Haskell in various contexts, like Facebook are using it for their spam policing, spam comments. A lot of banks are using it, like for financial trading and especially high-speed trading. I've got blockchain twice here. Various blockchain initiatives are also using blockchain like Cardano, for example. Okay, then a little bit about the Haskell ecosystem. Let me check my time. Okay. So basically, upstream, there's a kind of upstream repository called Hackage where developers might publish their packages. So it's called Hackage. And basically, it's just there's lots and lots of packages there, and not everything may install. It's basically just a very large collection of packages. And some may not be maintained anymore, and occasionally they're like deprecated versions. And then there's a tool called Cabal or Cabal install, which people can use which pulls down packages from Hackage and then tries to build them locally. There was a time when there was a lot of dependency issues and so on. It's actually improved quite a bit in recent years. One interesting aspect about Hackage is that packages can actually be revised. So after they've been published, it's possible to tweak like dependency bounds and so on. Because sometimes people put too tight bounds on dependencies and then they need to loosen them, for example. This is somewhat annoying for people doing packaging, but anyway. And each of the packages have a so-called cabal file, which contains all the metadata, like the name, version, description, dependencies, and so on. Maybe we just look at one example here. I think I have. Oops, that didn't work very well. Let me get out of full screen. Okay, it's already there, I think. Okay, this is a very small font. Anyway, so here's one. This is actually one of the packaging tools we use for converting these cabal files into RPM packages. And, well, there's a lot of information. Basically, this page is sort of a visual representation of the cabal file, but most of it. But down here is it. So it looks something like this. I don't know if you can see that. Anyway. So there's like, yeah, I mean there's the name and version, description and so on. And then further down here, dependencies are listed and so on. And there can be various conditional dependencies, so it's a bit complicated. And anyway, so just to give you an idea. And then there's a kind of downstream project called Stackage. So Hackage has got probably, I don't know how many packages are on Hackage, but there's probably tens of, I don't know, at least probably, well, sort of tens of thousands of packages on, I don't know, roughly, I don't know exactly. But Stackage is a downstream project trying to produce stable sets of packages, of Haskell packages. Currently there's about 2,600 packages in Stackage Nightly and also the Stackage LTS, which is a slightly more stable distribution. It's only a source distribution, so it's just a set of collection of consistent packages where dependencies are working together nicely and everything. And but they are actually built, so the Stackage build server builds the packages. When packages are updated, it'll automatically rebuild things and so on. So basically, now in Fedora we're tracking, we're trying to track basically Stackage because it sort of guarantees that things will build and so on. Previously, before Stackage, it was kind of more of a, well, we'd have to test very carefully before doing updates and so on. We didn't break anything and this kind of thing. And there's, okay, here's an example. I'll close it. Stackage website is a bit harder to read, but anyway. So anyway, this is the same package on Stackage. There's, well, anyway, there's some version information and so on. It contains somewhat similar information, but if I just take it to the top page. Yeah, so you can see what's happening here. Okay. That's probably enough about Stackage for now. And there's a tool called Stack, which is somewhat coupled with Stackage. It sort of tries to build things against sets, the package sets from Stackage, though it's not, yeah. So this is also getting more popular. Until now, we haven't actually, so this Stack tool, for example, is not in Fedora yet because the dependencies are quite heavy. But now we've recently added more packages, so it may be possible soon to build it. I haven't actually checked in a little while, but so I don't know. I already asked who uses Haskell, but anyone using any Fedora Haskell packages? Or not many. I mean, I think there's quite a trend that often developers just install things themselves. So I think a lot of Haskell developers will just use Stack or Cabal and build their own packages. So, I don't know. Sometimes there's a sense that, well, that just packaging libraries up is not maybe so useful. But of course, we have a lot of tools like Pandoc and shell check and so on. And those packages do need to have libraries, so we're kind of focusing more on just making sort of an ecosystem which allows those packages to be built. So, Fedora Haskell challenges. Well, currently we have about 450 packages, so it's quite a small subset of, well, say compared to Stackage. I mean, Stackage has a lot of stuff in it, and maybe not everyone needs all the stuff in there, but and we have a few packages which are not in Stackage, but nearly all of them are, I think. Another challenge is that GHC has very extremely tight version dependencies. So basically every dependency, binary dependency, is on an explicit version. So even if you do the most minor bump of a package, you'll need to rebuild everything above it. So this makes life a bit hard for Haskell packages. So I think typically we tend to just refresh package versions with it once, say, per release cycle, so once per each development cycle, though. It's not as strict. I mean, it's really up to the individual maintainers of packages, but to avoid a lot of churn, and we don't really backport that much version updates. One other small thing is that, well, it's probably a bit technical, but due to lack of packaging manpower, we even had to do some subpackaging of dependencies in a few packages, which has been a bit ugly, and well, we're trying to undo that kind of technical depth now. But and I just here wanted to acknowledge that various people over the years have contributed a lot to the project. So I just tried to write down. I'm probably missing a lot various people, but I got these names from the Haskell SIG page anyway. All right, let me check another time. Okay. So let's move on to talking about how we actually build the packages, or how we package and how we build them. There's a tool called, well, I think I showed you already, this Cabal RPM. Well, I didn't demonstrate it, but we looked at the page on Haskell and Stackage. So this tool can basically create RPM packages from Cabal packages. So you just, well, I could do a very quick demo maybe. So I'll make it a bit bigger. Not sure. So let me try and make a spec file for something. So let's try and do this. Let's see. Okay, so it's found that the latest package on Stackage is 2.06, and now it's created a spec file. Now it's actually created a library spec file because it's called the package GHC pandoc. By default, we just make library packages because, well, some packages create executables which are not really that important. So I think if I do this, I can't remember how to use this. Yes, well, it would help if I ran the right program, I guess. I'm not sure you can see that. All right, so now it's created a spec file for Panda. There's quite a lot of dependencies, you can see. Anyway, and so it can do various things like create spec files, create an SRPM, can download dependencies, install. It can also do recursive packaging, so if dependencies are not there, then it will create spec files for those and also build those for you. Okay, that's, and the other there's a few other features. It can do a diff, so it can compare your current spec file with a new pristine generated spec file, and it can also update a spec file to a new version of a package, and it can also refresh the packaging. So those latter two are a bit flaky because they're just basically applying diffs of pristine changes to the actual real spec file, and sometimes that doesn't work. So we should really parse more carefully, but we don't do that yet. Okay, that was Cabal RPM. And then there's one more tool, which is more doing the building kind of side. Actually, it's a set of tools called Fedora Haskell tools. So there's FH package, which basically, well, just quicker I show you. Let me try and make it a bit bigger. Oops. So FH package can do things like, it's a bit like Fed package, but it can do things like cloning, can do git diffs, it can, what else? Oh, it can also update, it can generate metadata for Hackage. I don't know if, okay, maybe we'll look at it later, but on the Hackage pages of packages are actually distro version info, so we upload those. And things like that. And then there is, okay, I think I'm running out of time, but build tool, which can do local builds, and it can also do mock builds, and it can also do builds to Koji, and it can also do recursive building on Koji, where it'll build missing dependencies as well. So that's basically how we're rebuilding packages currently. And the third tool is a tool to help update Bugzilla. Oh, actually, it's actually running, I think now. Yeah, it can basically update bugs in Bugzilla, checking what's available and stuff like that. All right, that's enough of that, I think. Then, okay, got a few minutes. Well, there's various things we want to improve. Let's see. Well, one is reliability, and also ideally we'd like to do async parallel building to speed up. Using Docker for local builds, and well, various performance and well, also yeah, ways to yeah. So I think that's about it. Oh, well, other distros. For example, Nixos has basically a whole of Hackage packaged, well, more or less everything. And OpenSUSE also has basically packaged the whole of Stackage, so all those 2,000 packages, or 2,600. So in that sense, Fedora is quite behind. A lot of Haskell developers like Nixos, for example, and they use Nix and so on. I think in the abstract I had something about continuous integration. It's something that we want to work towards. We haven't really even started to think seriously about it yet, but I'm hoping that some of the continuous integration efforts in Fedora will help to there. Yeah, so that's basically my talk. Does anyone have any questions or comments? We're always looking for more contributors. Oh, please. Can you speak up? I couldn't catch the whole question. Make it easier for what?
Give me a second.
Oh, thank you.
So, just what kinds of things are the people who are participating in the Haskell doing to help onboard other people, new blood?
Yeah, that's a good question. Probably not enough. We don't really have a lot of manpower. Recently, a few people got more involved. So for a long time, there was very few people even involved at all. But recently we've managed to package quite a bit. There's a few, I think, people who've been. So we have managed to package more recently, but it's difficult, I think. I don't really have a good answer. It's a good question, though. Any other questions?
Only 1 minute left, so one question. Okay, thank you.
Thank you very much.